Hello everyone, welcome to the course Structure Analysis. I am Dr.S.Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. Today we are at the 80th lecture, which is the analysis of beams using a theorem of three-moment equation, and this is the second lecture in theorem of three-moment equation. So in last lecture, which is 17th lecture, we discussed and we derived the equation for theorem of three-moment. Okay, so in today's lecture what we are going to do, we are going to take some numerical problem and then we are going to compute the final bending moment, and also we are going to draw the shear force and bending moment diagram for that. So at the end of this lecture, student can able to analyze the continuous beam using the theorem of three moment concept. So quickly I will take the example problem. So the problem is this: we have a continuous beam. Let's say all the supports are simply supported. So I have one roller support and two hinged supports. Span AB having 72 kilonewton at center. So this is 5 meters and this is 5 meters. Span AB is totally 10 meters. Coming to span BC, this is 36 kilonewton per meter. So the span of the BC is 8 meters. Okay, now the step 1 what I have to do is, step 1, I need to calculate the positive bending moment diagram for span AB and BC by considering the beam is simply support. Okay, so I am just going to consider the span AB and BC, even though in the real problem also it is a simply supported, but when we are dealing with the problem, sometimes we are going to have the fixed support also. Okay, in that case also we are going to consider as a simply supported beam. But in this problem, by nature itself, the given problem itself, it's a simply supported. So even though you can write these steps in the examination for better understanding. So let's consider as a simply supported, and then I am going to draw the bending moment diagram. Okay, so for span AB, if you draw the bending moment diagram, it's going to be like this. And this is the bending moment diagram for span BC. So this ordinate is nothing but W AB by L. Otherwise, both the formulas will be getting the same answer only. But let's put the appropriate equation here. Since it is a point load, I can say this is WL by 4. So this is WL by 4. So what is the W? 72 and then L is 10 meters divided by 4. For this, I will be getting the value which is equal to 180 kilonewton meter. What about this ordinate? This is UDL, so WL square by 8. So W is 36 and the second span is 8 square divided by, so I will be getting 288. Okay, so let's draw these diagrams once again here. The first one is a triangle, the second one is a parabola. So this is 180 and this is 288. This is 180 and this ordinate is 288. What about the span? This is 10 meters and this is 8 meters. Okay, now what I have to do, I need to calculate the area of the bending moment diagram. Let's say calculate A1 x1 bar equal to area of the first, this one. So area of the triangle is half into base into height we calculated, which is 180, into centroidal distance. Since it is a symmetrical, you see if you draw the dotted line here, the left hand portion and right hand portion are equal. Okay, that is called as a symmetrical. So if it is a symmetrical, we can put span by 2. Okay, so with this we can calculate the A1 x1 bar, value is 4500. Similarly, I need to calculate the value of A2 x2 bar. So for this diagram, the formula is the parabola 2 by 3 of base into height we calculated 288 into centroidal distance 8 by 2. Because here also you draw the center line, the left hand portion and then right hand portion both are equal. Okay, so A2 x2 bar, how much I am getting? The A2 x2 bar is 6144. Okay, so we calculated A1 x1 bar and then we calculated A2 x2 bar. Now, I am going to apply the theorem of three moment equation. Let's say this is MA L1 plus 2 times of MB L1 plus L2 plus MC L2 equal to minus 6 A1 X1 bar by L1 minus 6 A2 X2 bar by L2. Now, simply I can put the MA is 0 and then MC is 0. What is the reason? Once you see the beam, because support A is simply supported, support C also is simply supported. So, the moments are 0. So, the only unknown is MB. So, let us substitute the values 2 times of MB, span 1 is 10, span BC is 8, okay, equal to minus of 6. We calculated A1 X1 bar is 4500 by 10 minus 6 multiplied by A2 X2 bar 6144 by L2 is 8. Upon simplifying this, 10 plus 8, okay, 18 multiplied by 2, 36 times of MB equal to, this value is minus 2700 and then this value is 4608. So, 36 MB equal to minus of 7308. So, MB, the final moment is minus 7308 by 36, which is minus of 203 kilonewton meter. Okay, so you can observe here the unknown value in terms of moment is only one value, that is MB, because already we know that MA is 0, MC is 0, MB value only we have unknown, that is we calculated 203 kilonewton meter. Since it is a support moment, we have the negative value. So, it is very easy, right? So, by using the theorem of three moment equation, easily we can able to compute the end moments. Now, quickly we can calculate the reaction force and then we draw the shear force and then bending moment diagram for this. So, for that I have to go span by span. First I am considering the span AB, mark the moments, this is 0, this moment we are calculated which is 203, this beam having the central load of 72 kilonewton and the span of this is 10 meters. So, I am taking moment at the point B. So, just equating the clockwise couple and then add anti-clockwise couples. For example, so what is the clockwise couple here? RA multiplied by 10, I can say this is 10 RA. Then 203, the moment is in clockwise direction, anti-clockwise direction, 0 is anti-clockwise, plus 72 multiplied by 5 is anti-clockwise. So, I will be getting RA is equal to 15.7 kilonewton. Okay, it is very easy. And then I have to put all the vertical forces equal to 0 as per this condition. You can see RA is upward, then let us say this is RB1, RB1 is upward, minus 72 is in downward direction equal to 0. So, we have the RA value which is 15.7, RB1 value we do not know, minus 72 equal to 0. So, I will be getting RB1 equal to 56.3 kilonewton. Now, similarly, I have to go for the span, second span. If you consider the second span, it is subjected to UDL throughout the span, which is 36 kilonewton per meter, and the span is 8 meters. We know the MC value is 0 and support B we have 203 kilonewton. So, this is B and this is C. So, here we are going to have the RB2 and this is RC. Again I am taking moment at the point C. So, I can say this is RB2 multiplied by 8 is a clockwise direction, plus 0 is a clockwise direction, 203 is anti-clockwise, plus 36 multiplied by 8 multiplied by 8 by 2 is anti-clockwise. So, these are the moments. So, now RB2 equal to I am getting 169.375 kilonewton. Now, what I have to do? I need to put summation of all the vertical forces equal to 0. If I keep like that, So this is RB2 vertically upward direction, RC vertically upward direction, minus 36 multiplied by 8 is acting in a downward direction equal to 0. So we got the RB2 value, which is nothing but 169.375 plus RC we don't know, and this is 36 multiplied by 8 equal to 0. So RC is equal to 118.625 kilonewton. Okay, and one more thing we need to do is, for a RB value we need to calculate RB1 and then RB2. By summing up this value, I will be getting 225.67 kilonewton. Directly we can draw the shear force diagram. Before that, I need to draw the beam once again. Okay, and mark the UDL. This is 36 kilonewton per meter. At center, we have 72 kilonewton in span AB. So this is span AB is 10 meters, span BC is 8 meters. Let's mark RA we computed, which is 15.75. RB is 225.67. RC is 118.625. Okay, so let's take shear force at the point C is equal to. So when you are going left to right, you consider the upward forces are positive and downward forces are negative. When you are coming right to left, upwards are negative and downward forces are positive. Now I am coming right to left. So I am taking this value as a negative value, which is 118.625 kilonewton. Shear force at the point right of B. Why I am going right of B? Because right to the support UDL is there. Okay, so minus 118.625. So downward forces are positive. So plus 36 multiplied by 8, I am getting 169.375. Now the shear force at the point B, which is 169.375. At B, we have the reaction force going in a upward direction. So upward direction forces are negative we are considering. So minus of 225.67. So I will be getting minus 56.295, and shear force at the point D. So this will say D. So minus of 56.295. At the D we have a downward force which is positive. So this is plus 72. So I will be getting 15.7, and then shear force at the point A 15.7, and then we have the upward force which is, we need to put negative. So 15.7 equal to 0. This 0 represents we did the calculation correct. But actually what does mean? The shear force at A is not is equal to 0. The shear force at A is 15.7. Okay, let's draw the shear force diagram. This is A, B, C, and this is the point D. Shear force at A we have minus 118.625, and then shear force at B we have 2 points actually. This is 169.375, and another value is negative minus 56.295. At D we have it's 15.7, at A we have 15.7. Now how to connect this line? From B to C we have a UDL. So all the way it's going like this, and then it's coming in a downward direction, and then from between D to B we don't have any load, so horizontally it will move, and then it's going up and then joining this line. So this is positive, positive, negative, negative. So this is your shear force diagram. Similar way, let's draw the bending moment diagram also. So already we have drawn the positive bending moment diagram due to the load. So which is, for example, this triangle is ordinate is 180, and this parabola ordinate is 288. So this two diagrams already we calculated. What is the bending moment at the point B, which is 203. Simply joining this, I am going to get the bending moment diagram. 180 we need to draw little high actually. So this is 180, this ordinate is 180. Now connecting this line, and then we'll shade your bending moment diagram. So this is the bending moment diagram. Let's say this is positive, this is negative, and this is positive. This is your bending moment diagram. So as a summary, in this lecture what we have learned, how to solve a continuous beam using 3-moment equation. So by using this principle, we can able to solve any problem by given any loading condition, we can able to solve the problem. So in next lecture, I will come up with the new example. Okay. So thank you for watching this lecture. Thank you.